Joseph Sikorsky with partners Todd Svoboda, and this is our presentation. The HPC is kept cool by a coolant. At Michigan State University, there is a large water reservoir located near the engineering building. In order to minimize cost, it was decided to use this water source in our heat exchanger to reduce the temperature of the coolant. Due to many environmental factors, the coolant needs to be harmless if ingested. Due to this, inhibited propylene glycol, otherwise known as Dow frost, was used. For this project, the inlet temperature of water is 57 degrees Fahrenheit, and the outlet temperature needs to be less than or equal to 60 degrees Fahrenheit. The mass flow of the water was calculated using Newton's law of cooling. This was done using maximum daily thermal energy produced by MSU's HPC. In order to reduce the vibrations of the heat exchanger, it is paramount to have a minimum change of pressure. The more the device vibrates, the shorter the lifespan of the heat exchanger. Also, the cost has to be taken into consideration with the change of pressure, the surface area, and the material makeup of the heat exchanger. There are three types of heat exchangers that we looked at. The first one is a fixed tube heat exchanger, which is the most popular in the industry and most practical. The second one is a U-tube heat exchanger. This one seems to have a lot of vibrations and is extremely difficult to clean. The third one is the floating head exchanger. This one is the most advanced and has minimal chance of cross-contamination between fluids, but costs a lot to manufacture. The proposed design is a fixed tube heat exchanger. Two benefits of the fixed tube heat exchanger are that it is easily maintained and it is the most cost-effective design. MATLAB was implemented to solve for the ideal heat exchanger. Being optimized for in our design was the cost. It was desired to produce the lowest cost heat exchanger while successfully meeting the design constraints. This is our optimal results that we came up with through our MATLAB script. As you can tell, the effective result seems a little low, but that's because we wanted to optimize the cost. The more effective the heat exchanger, the more the design costs. Also designed for a low pressure drop had a huge factor on lowering the overall cost of the heat exchanger. This is our potential supplier. They're located in Toronto, Canada, OEI. In conclusion, the project was a success. We lowered the temperature of the coolant enough to continuously disperse the 1 megawatt thermal energy released from the HPC. The temperature increase of the water did not exceed the 60 degree Fahrenheit limit. Also, the change in pressure was minimized. Any questions?